All right, folks, this is going to be for number 13. So the projectile is fired in such a way that its horizontal range is equal to 3 times its maximum height. So I'm going to did this like I did last time. I'm going to define L to be the point X and Y. X specifically being V naught cosine of theta times the time, and Y being V naught sine of theta times the time minus g t squared over 2. This is going to be 13. G is going to be specifically 9.8 meters per second square. So what is the angle of projection to the point where its horizontal range, meaning D, is equals 3 times the maximum height? So it's just this. But I'm not going to worry about that yet. Because unlike last time, folks, we did already set this up. We find the time it took for the thing to reach its maximum height, which is going to be this equation. It's really just going to be this equation all over again. So I don't want to redo this again. And then now you're going to have the other equation. The other equation that I'm going to be using is this one, tangent of theta. This is the equation of x in terms of y, depending on what angle and the velocity is launched at. So that's really just going to be this equation at the end of the day. So that's going to be d minus g over 2 v naught square d square c square of theta. So the overall goal is to set up these two equations, folks. So once you set this up, what we're going to do is we're going to solve for v naught, and then we're going to chug it in there. We're going to combine these two equations, and we're going to get, and I guess I won't pause the video here, but you're going to get tangent of theta d minus g d square over 2. This is going to be cos square of theta. And once you chog it in there, once you solve for v naught, you should have this thing in the bottom, 2hg in the bottom, times 2 times g times h over the sine square theta on top. So now you have this equation. So now you're going to get that equation. And remember that the distance is going to be 3 times the height. So let's keep working with this. So now you have tangent of theta d minus, it looks like the g's cancel, so you're going to have 4h in the bottom, d squared times 4h, and then now you can have tangent square of theta. And this is going to ultimately be 0, so that's going to make things easier. So now you have tangent of theta, so that's going to be 1 plus times multiplied by 4h on both sides. Changing the signs, of course, 4h divided by d squared. And I think that's it. And I feel like something should cancel. I'm a little confused, folks, because I do believe something should cancel off. Anyway, let me fix this. I don't know where. I know this equation is correct. I know that much. So if h is some variable in terms of d, that d is just going to be 1d, and that's going to go away. But this one I didn't took that t. Oh, it's just okay. I know why. It's because of this, folks. There we go. Anyways, sorry if I'm talking to myself. Anyway, so there's the equation, folks. All right, now we're going to take into the account that the distance is going to be 3 times the height. So is that it? Yeah, 3 times the height. So now we're going to let d equals 3h. So now you're going to have tangent of theta in this specific case is going to be 4/3 of that. So tan inverse of 4/3 will be the result, I'm pretty sure, if I did the math correctly, which is going to be 53.1 degrees. So once you do the math, folks, tangent of theta to be 4/3, theta is going to be 53.1 degrees. And in order to get that, you just take 10 inverse of 4/3 to get that angle theta. And that's it, folks. That's all they need. All right. Goodbye. I hope you guys enjoyed.